onto functions. These are functions where the codomain and the range or image are equal. This means that for every element in the codomain, it is the image of some element from the domain. That leads us to the definition. Onto definition. A function f from a to b is called onto, or a surjection, if and only if, for every element b in set B, there is an element a in set A with f of a being equal to b. A function is surjective if it is onto. A function is onto if for all y there exists an x such that f of x is equal to y, where the domain for y is the codomain for the function. We can take a look at a graphic for this, and we can map elements a to 3, element b to 2, element c to 1, and element d to 3, and see that this function is onto, because every one of the elements from the codomain is mapped to some element from the domain. So the range, or the image, is equal to the codomain, and that makes it onto. Let's take a look at an example. Let f be the function from a, b, c, d to 1, 2, 3, defined by f of a equals 3, f of b equals 2, f of c equals 1, f of d equals 3. Is f onto? And the answer will be yes, because every element in the codomain is mapped by an element of the domain. That is, every element in the set 1, 2, 3 is mapped to by some element from the set A, B, C, D. Next example is function f of x equals x squared from the set of integers to the set of integers onto. And the answer would be no. Counterexample. X squared equals 3. There is no value for x in integers that would equal the value 3. So not every element from the codomain is mapped by an element of the domain. Next, we'll take a graphical look at examples of types of functions. The first one we'll look at is the one I already have pre-drawn out on the top left side. We'll take element A and map it to 3. Element B maps to 4. Element C maps to 1. This is 1 to 1 because every element in the image maps to exactly one element from the domain. However, it is not onto because the codomain set 1, 2, 3, 4 has an element number 2 that is not the image of any element from the domain set. So that is 1 to 1, but not onto. Next, we'll look at a set that is onto, but not 1 to 1. This is domain set A, B, C, D codomain set 1, 2, 3 with element A mapping to 2, B mapping to 1, C mapping to 3, and D mapping to 2. Since A and D both map to 2, this is not one-to-one. But it is onto because every element from the codomain is an image of an element from the domain. Next, we'll look at one that is one-to-one and onto. And this is domain set ABCD, codomain set 1, 2, 3, 4. Element A maps to 4. Element B maps to 1. Element C maps to 3. Element D maps to 2. Every element in the codomain is mapped to by an element from the domain, so that is onto, and every element in the image is mapped to by exactly one element from the domain, so it is one-to-one. Next, we'll look at an example that is neither one-to-one nor onto. The domain set is ABCD. The codomain set is 1, 2, 3, 4. Element A maps to 2. B maps to 1. C maps to 2. And D maps to 3. So in this case, we have element 4 that has no mapping, therefore this thing is not onto, and we have element 2 that is the image of A and C, meaning that it's not one-to-one. The next example we'll take a look at is not a function at all. We have domain set ABC, codomain 1, 2, 3, 4, and A maps to 2 as well as A mapping to 4. B maps to 1, and C maps to 3. Since we have one element from the domain that maps to 2 elements in the codomain, that makes it not a function.